Hello and welcome back to Geometry, Chapter 10, Section 6. We're talking about segment relationships in circles. Okay, there are going to be three different ones. We're going to look at when segments cross inside, so segments of chords. That's theorem 1018. We're going to look when we have intersections outside and inside, so segments of secants. And if you have a segment outside, you got a secant and a tangent, then that's segments of secants and tangents. All right, so all these theories are aptly named. And if you look at this segment right here, kind of cool. You take this segment AB, and AB times BC is equal to EB times BD. So these segments, this segment times that segment, is equal to this segment times that segment. In secants, okay, we're going to look at the outside, and then we're going to look at not just the inside, but the entire length. So we have from A to B times A to C. So the short segment outside times the whole length. So here we're going part to part. Here we're going part outside to whole. Okay, so part times whole. Same thing over here, part times whole. I've written the other way around, doesn't really matter. Commutative property, whole times part, how you write it. Okay, now in tangents, it works the same way as secants, except the point, it doesn't ever intersect the circle, right? So there's no outside or whole. So the part outside, so B basically is the same point as C. So I'd have the outside point and the whole, that's the same thing. So I do AB times AB. So I get AB squared, and then for the secant, I do the same thing, part times whole. Okay, so segments of chords, part times part. Segments of secants, part times whole. And tangents is also part times whole, but on the tangent, the part is the whole. So that's why we just take that squared. All right, so here we go. We've got chords, so we're going to do part times part. So x times 3 is equal to 6 times 4. And that gives us 3x is equal to 24. Divide by 3 on each side. That was a 4. 24 divided by 3 is 8. X is 8. Okay, that was an easy problem. This one's a little more challenging. Set it up the same way, but now you've got to remember a little bit of your algebra, right? And here we have part times part, so x plus 2 times x plus 1. All right, here, distributive property, x squared plus 4x. On this side, we can use the box method or FOIL method, either one works. I'll go ahead and entertain you and do the FOIL method. Okay, first, x times x gives me x squared. X times 1 gives me 1x. X squared. 2 times x gives me 2x, and 2 times 1 gives me 2. Here we have 3x, so that's x squared plus 3x plus 2. Over here we have x squared plus 4x. All right, now I can subtract x squared from each side, cancel those out, subtract 3x from each side, and then x is equal to 2. Now, that was not the question, so I'm going to go back here and find ML. All right, ML is x plus 2 and x plus 1. Add those together, that's 2x plus 3. So plug in x, so 2 times 2 plus 3 gives me 4 plus 3 is 7. ML is 7. And then JK is 2 plus 2 plus 4 and that gives me 8. All right, here we have two secants. Remember, we do part times whole. All right, so 9 times 9 plus 11 is equal to part times whole, 10 plus x. All right, 9 times 9, 81. 9 times 11, 99 is equal to 100 plus 10x. And solve that. Add up, subtract 100, divide by 10. X is 8. All right. Here we have a tangent and a secant. So again, we do the short times, or part times the whole, but that's both the same. So we do x times x here, or x squared, is equal to short 1 times the whole times 3 plus 1. Okay, 3 plus 1 is 4, times 1 is 4, x squared is 4, square root of that, x equals 2. All right, easy example. Now a little more challenging here. Doesn't look a lot harder, but notice that the x is now on this side. So now we have 10 times 10, or 10 squared, is equal to part times whole times x plus 15. Okay, and that gets me 100 is equal to x squared plus 15x. Now, how do we solve that for x? Okay, I can't cancel out any x over here. All right, back to your algebra days. We set this equal to 0 by subtracting the 100. All right, we got 0 there equals x squared plus 15x minus 100. So we're looking at what multiplies to 100 and adds to 15. So we're multiplying to 100 and adding to 15. Okay, 100 is 10 squared, but 10 times 10 does not give me 15, or 10 plus 10 does not give me 15, so try 20 and 5. It has to be negative, so negative 20 and 5 will give me negative 15. 20 and negative 5, so 20 and negative 5 will give me negative 100, and 20 minus 5 will give me 15. All right, so there are my factors. And then we have x squared here, so it's going to be x minus 5. And x plus 20 equals 0. Okay, so either x is 5, that would make this here 0, or x is negative 20, that would make this 0. So, now, being a distance, negative 20 doesn't make any sense, okay, because a distance can't be negative, so x has to be 5. And therefore, RS is 5. Okay, find the find the radius of the aquarium tank. There's the little sharky shark swinging around. Daddy shark, doo 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 doo. And we've got a tangent and a secant. We take the tangent times the tangent, or squared, and then the secant we do part times whole. 8 times the whole, which is r plus r, so 2r, plus 8, plus the 8. All right, now 8 times 2r gives me 16r. 8 times 8 gives me 64. And then over here, we have a d400. Subtract 64, we got 336 is equal to 16r. Divide each side by 16. And 336 divided by 16 is 21. 21. Now, that is what they were looking for, the radius, so There you have it, ladies and gentlemen. Good times in the Matherhood.